maximum wattage allowed on a 240-volt 20-amp circuit is 4,800 watts. This calculation is based on a simple formula. Wattage equals voltage times amperage. In this case, the wattage is calculated by multiplying 240 volts by 20 amps, which equals 4,800 watts. Therefore, the maximum wattage that can be safely drawn from a 240-volt 20-amp circuit is 4,800 watts. It is important to not exceed this wattage limit to avoid overloading the circuit and potential electrical hazards. Understanding electrical circuits is crucial for safety and efficiency. Overloading a circuit can lead to various problems, including tripping the circuit breaker, damaging appliances, or even causing a fire. Therefore, it's essential to know how to calculate the maximum load a circuit can handle and ensure that you don't exceed that limit. When working with electrical circuits, always prioritize safety. Before starting any electrical work, turn off the power to the circuit at the breaker box. Use appropriate tools and safety equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it's best to consult a qualified electrician. Now let's delve deeper into the concepts that are related to this calculation. Firstly, consider the components involved in a standard electrical circuit. A circuit needs a power source, which is the 240-volt supply in our example. Secondly, the circuit requires conductors, which are wires that carry the electrical current. Thirdly, a circuit also needs a load, such as an electric baseboard heater, which consumes electrical energy and converts it into heat, light, or mechanical work. A circuit breaker is a safety device that protects the circuit from overloads and short circuits. When the current in a circuit exceeds the breaker's rated capacity, the breaker trips, interrupting the flow of electricity and preventing damage to the circuit and connected devices. Circuit breakers are typically rated in amps, indicating the maximum current they can safely handle. The 20-amp circuit breaker in our example is designed to protect the circuit from currents exceeding 20 amps. Now consider the National Electrical Code, or NEC, which provides guidelines for safe electrical installations. The NEC specifies the types of conductors and circuit breakers that must be used for different types of circuits and applications. It also sets limits on the maximum load that can be connected to a circuit. In general, the NEC recommends that circuits not be loaded to more than 80% of their rated capacity. This safety margin helps to prevent overheating and other problems that can occur when circuits are continuously operated at their maximum capacity. In the case of a 20-amp circuit, the NEC recommends that the maximum continuous load not exceed 16 amps, which is 80% of 20 amps. To calculate the maximum wattage for a continuous load on a 240-volt 20-amp circuit, you would multiply 240 volts by 16 amps, which equals 3,840 watts. Therefore, the maximum continuous load that should be connected to a 240-volt 20-amp circuit is 3,840 watts. Understanding the difference between the maximum wattage and the maximum continuous wattage is crucial for safe and reliable electrical installations. The maximum wattage is the absolute limit that the circuit can handle under ideal conditions, while the maximum continuous wattage is the limit that should not be exceeded for extended periods. When selecting electric baseboard heaters for a 240-volt 20-amp circuit, it's important to choose models that have a total wattage that does not exceed the maximum continuous wattage of the circuit. For example, you could install two 1920-watt baseboard heaters on a 240-volt 20-amp circuit, since their combined wattage of 3,840 watts does not exceed the maximum continuous wattage. However, you could not install two 2400-watt baseboard heaters on the same circuit, since their combined wattage of 4,800 watts exceeds the maximum continuous wattage and the overall maximum wattage of the circuit. In addition to considering the wattage of the baseboard heaters, it's also important to consider their placement and installation. Baseboard heaters should be installed in accordance with the manufacturer's instructions and local electrical codes. They should be placed away from flammable materials such as curtains and furniture, and they should be properly grounded to prevent electric shock. It is also important to ensure that the wiring for the circuit is in good condition and that the connections are tight and secure. Loose or corroded connections can cause overheating and increase the risk of fire. If you are unsure about any aspect of the installation, it's best to consult a qualified electrician. When calculating the maximum wattage for a circuit, it's also important to consider the voltage drop in the circuit. Voltage drop is the decrease in voltage that occurs as electricity flows through the wires from the power source to the load. Voltage drop can be caused by the resistance of the wires, the length of the wires, and the amount of current flowing through the wires. Excessive voltage drop can cause appliances to operate inefficiently or even to fail. To minimize voltage drop, it's important to use wires of the appropriate size and length for the circuit. The NEC provides guidelines for wire sizing based on the circuit's current and the length of the wire run. In general, larger wires have lower resistance and result in less voltage drop. In addition to wire size, the type of wire used can also affect voltage drop. Copper wires have lower resistance than aluminum wires, so they are generally preferred for electrical circuits. However, aluminum wires are less expensive and lighter than copper wires, so they are sometimes used in certain applications. If you are using aluminum wires, it's important to use connectors and terminals that are specifically designed for use with aluminum. Aluminum connections must be properly treated with an antioxidant compound to prevent corrosion. The temperature rating of the circuit components also plays a crucial role in ensuring safe and efficient operation. Circuit breakers, wires, and other components are designed to operate within a specific temperature range. Exceeding the temperature rating of a component can cause it to fail prematurely or even to create a fire hazard. The NEC specifies the temperature ratings that must be used for different types of circuits and applications. It's important to select components that have temperature ratings that are appropriate for the environment in which they will be installed. In addition to temperature ratings, the NEC also specifies the types of overcurrent protection that must be used for different types of circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect circuits from overloads and short circuits. When the current in a circuit exceeds the rating of the overcurrent protection device, the device trips, interrupting the flow of electricity and preventing damage to the circuits and connected devices. The NEC specifies the size and type of overcurrent protection device that must be used for different types of circuits. It's important to use the correct overcurrent protection device to ensure that the circuit is properly protected. When calculating the maximum wattage for a circuit, it's also important to consider the effects of harmonics. Harmonics are distortions in the alternating current waveform that can be caused by certain types of electronic equipment, such as computers and variable frequency drives. Harmonics can increase the current flowing in a circuit, which can overload the circuit and cause the overcurrent protection device to trip. To minimize the effects of harmonics, it's important to use equipment that generates low levels of harmonics and to install harmonic filters on circuits that are susceptible to harmonics. In addition to the factors discussed above, there are several other considerations that are important when working with electrical circuits. These include the proper grounding of equipment, the use of ground fault circuit interrupters, or GFCIs, in wet locations, and the proper labeling of circuits and equipment. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault currents to flow back to the power source. Proper grounding helps to prevent electric shock and other electrical hazards. GFCIs are devices that detect ground faults and interrupt the flow of electricity to prevent electric shock. GFCIs are required in wet locations such as bathrooms, kitchens, and outdoor areas. Labeling of circuits and equipment is important for identifying the purpose of each circuit and the rating of each piece of equipment. Proper labeling helps to prevent accidental overloads and other electrical hazards. Finally, it's important to remember that electricity can be dangerous if not handled properly. Always follow safe electrical practices and consult a qualified electrician if you have any questions or concerns. The concepts we've discussed, like understanding voltage, amperage, wattage, circuit breakers, and the NEC guidelines, are fundamental to working safely and effectively with electrical systems. For example, When installing a new appliance, you must first determine its wattage. Then, you need to identify the appropriate circuit to connect it to, ensuring that the circuit's capacity is not exceeded. This involves checking the voltage and amperage of the circuit, calculating its maximum wattage, and comparing it to the appliance's wattage. If the appliance's wattage is too high, you will need to install a new circuit or find a different location for the appliance. Similarly, when troubleshooting an electrical problem, understanding these concepts can help you to identify the cause of the problem and determine the appropriate solution. For example, if a circuit breaker keeps tripping, it could be due to an overload, a short circuit, or ground fault. By understanding the characteristics of each type of fault, you can use a multimeter to test the circuit and identify the source of the problem. In summary, calculating the maximum wattage for a 240 volt 20 amp circuit involves understanding the relationship between voltage, amperage, and wattage, as well as following the guidelines of the National Electrical Code. By adhering to these principles, you can ensure that your electrical installations are safe and reliable.